Good day, class. In this lesson, I will demonstrate how to find the GCF of a polynomial. So when we're talking about the GCF, we're talking about the greatest common factor. That's an acronym for greatest common factor. And when we're dealing with the greatest, we're looking for the largest number. And then when we're talking about common, we're talking about the number that they share, a number that they have in common. And so we need to look at the factors of, for example, 6 and 12, because we're looking for the greatest common factor between 6 and 12. And so I'm thinking of the factors of 6, and 2 and 3 are certainly factors of 6. We'll just ignore right now 6 times 1 just to keep this simple, but sometimes it will be important for you to use that factorization, the 6 times 1, the number times 1. But in this case, just keeping it simple, let's look at 2 times 3. And in terms of 12, let's look at 4 times 3, and let's look at 6 times 2. These are all the factors of 6 that we want to consider and factors of 12 that we want to consider in this case. And then, of course, I like the 2 times 3 only gives us this single choice. And then I like the 4 times 3 because that 3 is showing up in both factors of the 12. With the 12 and the 6. So this is a factor that they have in common, and it's the biggest number that they have in common. So we'll use that as our greatest common factor. Let's look at a similar set of terms. On the left, we're dealing with 6x. On the right, we're dealing with 12x. We're looking for the greatest common factor, or the largest number that they both have in common with one another. And so the factors of 6x, we'll look at 2 times 3 times x. That makes 6x. And the factors of 12x, we'll look at 6 times 2 times x, or we can look at 4 times 3 times x. Either of those will work. So that, once again, that 3 is jumping out at me because they're common factors, they're shared, but also that x is jumping out at me as well. Those are shared factors, or factors that they have in common amongst both terms. So let's go with 3x as our greatest common factor in this case. So very quickly, this is kind of a similar example. We're looking at 21 and 35, 21x on the left, 35x on the right. And the greatest common factor, the largest number that they have in common with each other, is 7 times x, because they both actually do share that x. So we'll bring that with us as a part of the greatest common factor. In this example, we have 21x squared on the left and 35x on the right. So we're comparing these two. I'll say that between the 21 and the 35, just like in our last example, 7 was the largest of the numerical factors. And then in terms of those x's, let's take a careful look. We have 7 times 3 times x on the left. That makes the 21x squared. And then we have 7 times 5 times x on the right, which makes 35. So we like those 7s. We agree that those are common factors. We also like those x's, but we can only get one shared x and kind of leave back one of the x's on the 21x squared. So actually we can only get these. These are the factors that they both have present. So we'll go with 7x as our greatest common factor. So this is a very similar example. The only thing I've done here to change the example was to add an additional power of x on the 35x to make it 35x cubed. So you see that these examples are similar so that we can see some of the behavior, what's going on here. We'll look at the factors of 21x squared. We have 7 times 3 times x times x. That gives us 21x squared. So we factored that. We're demonstrating what factors make up 21x squared. And then on the right, we have 7 times 5 times x times x times x. Okay, so it's important that we recognize that 7 is shared. That's the biggest numerical value that's shared. And 2 of the x's are shared. So notice, the 7 is definitely appearing in both sets of factorization. And we can get up to 2 of those x's out where they're shared. So we'll go with 7 times x, or 7x squared is our greatest common factor. In this example, we're doing the same thing, except you have a binomial, okay? You have a polynomial with 2 terms. Our first term is 21x squared, and our second term is 35x cubed. So these are actually working together, and you're tasked with determining what is the greatest common factor found between these two terms with respect to the polynomial. So you have to not only pull out that greatest common factor. Remember, we just pulled that out in our previous example. So you pull out that greatest common factor, and then you have to tell what is left behind. What did you leave behind? Well, in this case, when we pull the 7x squared out of the 21x squared, we actually left behind a 3. When we pulled the 7x squared out of the 35x cubed, we actually left behind 5x. And I'll tell you why. 7x squared times 3 is what gave us 21x squared. And 7x squared times 5x is what has given us 35x cubed. So you're always going to have to go back and double check and make sure. I think I know what was left behind. I think I know what was multiplied or what factors made up this original term. So I know what I left behind when I took out my greatest common factor. This is the art of factoring polynomials by the greatest common factor, or pulling out the greatest common factor. So you will be challenged with what we call factoring in this course. So let's take a look at this problem again. We've been asked to factor 21x squared plus 35x cubed. Factoring is also known as the art of unmultiplying. It's just another word for factoring. Well, it's actually a made-up word, but unmultiply is what we want to grasp. So in order to unmultiply this one, we're going to use the method that we know as finding the greatest common factor. So you'll find the greatest common factor, 7x squared. You identify what has been left behind, and you will call this the factored form of your original polynomial. So our original polynomial is 21x squared plus 35x cubed, and the factored form of that polynomial is 7x squared times the quantity of 3 plus 5x. Here it is written in words. Remember, factoring takes practice. So there's no more extra reason for me to continue with the examples. Contact me at any time if you need to see additional examples, but it's important for you to jump in there and start practicing.